Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. In the last video, we were using Python, and now in this video, we will talk about the language fundamentals. Let's get into it. The objectives for this session are talking about Python's lexical analyzer and using whitespace to structure the programs in Python. Also, we'll talk about identifiers and keywords and Python's execution model, the data model, and we'll wrap up with creating and using some variables. So, the lexical analyzer. A Python program is a series of logical lines. A logical line is constructed from one or more physical lines by following the explicit or more implicit line joining rules. The end of a logical line is represented by a new line token. A physical line is what you see when you write the program, while logical line is what Python interprets as one statement. So in other words, a logical line can be broken up to one or more physical lines. A comment starts a hash character that is not part of the string literal and ends with the end of the physical line. So you can continue a line onto a second line. So you can have two physical lines that, and we're going to show you this in a second, but just if you end a line with a backslash, then physically you'll have two separate lines, or as many as you want, each one ending with a backslash. But according to Python, it'll be one logical line. So if your comment is the first or second line and the script matches a regular expression, coding equal, then a space. If you don't know regular expressions, it's a good thing to learn. So coding can be followed by either an equal sign or a colon, followed by one or more space, white space characters, like a space or a tab. And then one or more words. So this will be, if you have a line that says coding equals Latin 1, this comment will be processed as an encoding declaration. We'll show you that. Actually, so we want to talk about the line joining rules. An explicit line joining, where two or more physical lines may be joined into logical lines by using the backslash character. When a physical line ends in a backslash that's not part of a string literal or a comment, it's joined with the following line. The preceding line forming a single logical line. The line ending with backslash cannot carry comment. Implicit line joining. Expressions in parentheses, square brackets, or curly braces can be split over more than one physical line without using backslashes. Implicit. So that's usually how we do it. It's not a good idea, at least I don't like using backslashes. To end a line with a backslash, it seems very Windowsy. Implicitly continued lines can carry comments. Using whitespace to structure programs. That's one of the distinguishing characteristics of Python, is that you don't use semicolons or curly braces, although you can use semicolons. But curly braces define blocks in other languages like Java, whereas whitespace is what's used in Python to structure programs. Python programs get structured through indentation. In other words, code blocks are defined by their indentation. It's a language requirement, not a matter of style. This principle makes it easier to read and understand other people's Python code. All statements within the same distance to the left belong to the same block of code. In other words, the statements within a block line up vertically. The block ends at a line less indented or the end of the file. If a block has to be more deeply nested, it's simply indented further to the right. We're going to see all this. And at first, when I first started using it, I really loved curly braces, but because I could indent it any way I wanted. And I said, "Oh, this sounds like Visual Basic had that same." So it sounded very much like Visual Basic. I didn't like it. I didn't like being forced to indent it the way, I didn't like the indenting, but I grew to love it. Because like Guido says, Python is read far more than it is written. So it does help with readability. Using white space to structure programs. Okay, so here is a line of Python code. So we do an import statement. And then on the next line we get some input from user and assign it to a variable called n. Then we increase n by 1. Increment it actually. And then we start a for loop. And this is all in block 1. This is all in the main block. But as we get into the for loop, we're now going to start a new block. As you can see, there's indentation here. And the first line of this new block is also a for loop, so we're going to indent a further 4 spaces and continue with a third block. And the third block continues down with declaring a c² variable and a c variable and then an if statement. But the if statement itself starts a new block. So there's a 4th block starting. So the first block, second block, third block, and then a 4th block is starting. Identifiers and keywords. Identifiers are referred to as names. They can be referred to as names. Within the ASCII range 0 to 256, the valid characters for identifiers are the uppercase and lowercase letters A through Z, the underscore, and, well, the underscore, except for the first character, can be 0 through 9. So you can't start a variable with 0. You can't say 0x equals 9. 0x equals ABC. 0x equals a list. You can't have a variable that begins with a number. But you can say x0 equals anything. So, keywords. The following identifiers are used as reserved words or keywords of the language and cannot be used as ordinary identifiers. Python's execution model. A Python program is constructed from code blocks. A block is a piece of Python program text that is executed as a unit. The following are blocks: a module, a function body, class definition. Each command typed interactively is a block. A script file, a file given as standard input to the interpreter or specified in command line argument to the interpreter, is a code block. A script command, -C option, is a code block. The string argument passed to the built-in functions eval and exec are code blocks. Those are all different ways to tell the interpreter what code you want it to interpret. Script file or command line or an eval, exec function call. A code block is executed in an execution frame. A frame contains some administrative information, user debugging, and determines where and how execution continues after the code block's execution has completed. Naming objects and object binding. An object can be referred to by multiple names. Binding a name to an object doesn't change it. Changing some property of the object, however, will be reflected in all other names bound to that object. For example, consider the below list object with two different names, A and B. Both these names will point to the same list object. If we change the value of a list object variable A, it will be reflected in B as well. So we can set A equals B equals the list 145. So then if we take the list A, index 0, which is the first element, sequences are 0 indexed in Python, as most other programming languages. 0 index means they start at 0, so this is index 0, index 1, index 2. So A sub 0, as we say, we set that to the value 3. So we read this as A sub 0 equals 3. And then now we print A, and now you can see it's 345. It was 145. Now it's 345. Now if we print B, it's also changed. Even though we didn't change B, we only changed A. But since these two things both are just names, think labels, not boxes. So the label A points to this object, and label B also points to this object. So when the object was changed, either label we use to get to the object, we see that the value is changed. Python objects, values, and types. Everything in Python is an object, including variables and functions. Every object has an ID, a type, and a value. Let's create a simple object and see the value type in the class. So we create a variable x, which is equal to 5. Then we display the value of the object. Once we're inside of the interpreter, we can just type the value and it prints out for us. And we can see that if we type it, use the ID function to print off our x, we see the value is 5 and the ID is this big number, integer number. And if we print off the type, then we'll see it's of the class int. Mutable and immutable objects. Objects in Python are mutable or immutable. Mutable objects can change values, immutable objects cannot. Some immutable objects look like they are changing values. Some immutable objects look like they're changing values, but that does not happen. Let's see in the below example. Note that the integer value is an immutable object. So we created a variable pointing to an integer object with a value of 5. And we display it, and we call that object with the ID function, and we get the ID. Now, let's note that ID. And now, here we don't change the value of an integer object, we just point it to a different integer object. So now we set, before we had x equals 5, and now we have x equals 6. So those are two different objects. One object is 5, one object is 6. And now when we print off x, its value is 6, and it has a different ID. So it's a different object. So x doesn't change. X just points to two different objects. Creating and using variables. A variable is a way of referring to, and before we get too far down the list, let me talk about mutable and immutable objects for a second. Let's Let's look at this article from the Invent with Python blog from 2018. Now, this is a pretty good article here, posted by Al Zweigart. So, are tuples mutable or immutable? Now, most people say that tuples are immutable. So, mutable means changeable. Immutable means unchangeable. So, in Python, tuples are immutable. And immutable means the value cannot change. These are well-known basic facts of Python. While tuples are more than just immutable lists, as chapter 2 of Luciano's book Fluent Python explains, there's a bit more ambiguity here. So the title of this article is Python tuples are immutable, except when they're mutable. So if you want to check this article out, it's under, you can go to inventwithpython.com, and I'll just briefly skim over it, but he's talking about the same thing as we're talking about now with the ID, getting the ID of a variable, and you get two different variables and they point to two different objects. Same thing with A and B, spam and eggs both point to this object. Make it a little bigger here so we can read it, huh? But the thing is, tuples can hold hashability. We're going to cover this later. Hashability, according to the glossary in the official Python documentation, an object is hashable if it has a hash value which never changes during its lifetime. So sometimes when you try to use different objects in Python, you'll get an error that says it's not hashable. We're going to cover that later. But hashability and immutability are similar, but they're not the same thing. Immutable objects can be hashable. Mutable objects can't be hashable. It's not possible to hash a list, but you can hash a tuple, unless you can't. So that's what we're talking about here, is the mutability of tuples. Error, unhashable type, dict. So it seems that if a tuple contains a mutable object, it can't be hashed. Raymond Hettinger, if you don't know who Raymond is, you want to keep an eye on him. He's a very listenable Python expert. He explains with lots of context why immutable tuples can contain mutable values. See, there's a tuple here that contains a list. So here is a tuple with all three entries are mutable, immutable values. A string is an immutable object. So you can use this mutable object as a key for a dictionary. We'll talk about that later. But here, if we try to use a tuple with a mutable list inside of it, we get an error, because this could be changed. And we're going to talk about that too. We'll see how we can do that. All right, so are tuples mutable or immutable? We go down to the epilogue. The question is, said Humpty Dumpty, which is to be master? The words are the human. So basically, this guy says he thinks I'm going to continue to say that tuples are immutable, even though it's possible to create mutable tuples. Let's see if we can do that. Is that possible? Let's enter Python, our interpreter here. Now if we say x equals 1, 2, 3, now can we hash x? Ah, there's our hash for x. Now if we say x equals 1, 2, 3, now 3 is a list. Now let's try to hash it. Oh, we can't hash it. Unhashable type list. List can't be hashed. So, okay, let's go one step further. Let's look at x sub 2. That's a value 3, right? So we can say x sub 1 is 2 and x sub 0 is 1. So x sub 3, x sub 2 is the list 3. So we can say x sub 2 sub 0. What do you think that's going to be? So we took the index of x, index 2 of the tuple x, gave us a list, and we took the index 0 of that list, and we got 3. So now let's change it. All right, so let's look at x. That's x. So we get that 3 again. And now let's set this to a value of, oh, no error. So apparently, right, type x tuple. But apparently tuples are mutable. Interesting. So it's a nice title. Tuples are immutable. Until they're not. All right, let's get back to it. Now, a variable is a way of referring to a memory location used by a computer program. This memory location contains values like numbers, text, or more complicated types. We can use this variable to tell the computer to save some data in this location or to retrieve some data from this location. While the program is running, variables are accessed and sometimes changed, i.e. a new variable will be assigned to a variable. A new value will be assigned to a variable. You can, like we just did. Assigning values to the variables can be realized with assignments, with the equal assignment operator. There is no declaration of variables required in Python. If there's need for a variable, you just think of a name and start using it. So you don't have to define anything. You just say x equals 1. You don't have to define x anywhere. That's it. That's the definition of x in the assignment. Value and type of a variable can be changed during program execution. So the variable actually doesn't have type. The variable points to objects that have type. So it's not that the variable changes type, the value of the variable changes. In other words, the object that the variable points to changes. Points to a different object with a different type, perhaps. All right, so here we don't have to declare x anywhere. We just say x, we use the equal operator. We say x equals 27. So we're defining x, and implicitly it is an integer with the value 27. Now we say x equals 28. So the value of the variable changed because the value is the memory address. So now the variable points to a different object, 28. Here's an object in memory somewhere, 27. X was pointing to it. We create a new object in memory with the value 28, and now x points to that one. And now we take that same object and we create a third object. It's a float, 0.5. We add them two together, create a new object, a fourth object for that, and now x points to that. Now we create a fifth object, a string, and now x points to that. Python has many different built-in types, and it is possible to define your own. The principal built-in types are numeric, sequences, mappings, classes, instances, and exceptions. But let's focus on the following types: the numerics, strings, lists, tuples, and dictionaries, also known as dicts. Numbers are immutable data types which store numeric values. Number objects are created when you assign value to them. So x equals 1, it creates a numeric object. Del x, it deletes it. Pretty simple. So you can do, and then the next time garbage collection runs, you will free up that memory space. Python supports different numeric types: integers, floats, and complex numbers. So integer like 1, a float like 1.5, and a complex number like pi, for example, or some fractions. Python converts numbers internally in an expression containing mixed types to a common type for evaluation. Sometimes you need to convert a number explicitly from one type to another to satisfy the requirements of an operator or a function parameter. So int of x, you can convert whatever x is. Let's say x is 1. Now we convert x to an integer. Well, it already was an integer, so it's still an integer. We can convert it to a float, so it'll be 1.0. Complex, it'd be 1. And complex of 1 and y, let's say y is the imaginary part. And you need to get into complex numbers to find out what's going on there. Strings are the most popular immutable data type in Python. String data types can be created by enclosing characters within quotes. For example, x equals hello world. Substrings of strings can be accessed using the square brackets for indexing, like x sub 1 would give us, what do you think x sub 1 is going to give us? It's not the first character, right? It's at index 1. And since strings, like other sequences in Python and most every language, are 0 indexed, 1 would be the second character. As we can see here, it's e. So now we print, starting at 1, we print the first 5 character up until but not including the 5th character, or index 5, I should say. So that would be, yeah, the 5th character. And we can print starting at nothing, which is the beginning, and we print 3 characters. This is actually index 3. A multi-line string can be created using escape character for printing. So if we have the string first line, second line separated by a \n, which is a new line character, then when we print it out, we're going to get the new line character here at the end. Now if we want to actually print the \, we can either double \/ it, or we can make the string a raw string by using an r. It looks a little weird because the r is actually right at the beginning of the string, outside the quote. But then when we print it, it just prints off the \, as a normal \. And if you don't know about backslashes, they're much like the space. It's a special character. You gotta watch out for spaces and backslashes. Backslash usually begins an escape sequence. In this case, escape sequence is the non-printable, well, you can't see it. It's a new line, or a line, as they say in teletype, line feed. But if you use a raw string, then it will actually just look at the \, as a normal character to print out. So no new line is printed. Python lists. All right. Lists can be updated, providing the index values on the left side of the operator. So if we have, for example, let's say fruits equals apple, mango, and then we want to say fruit sub 2. What fruit do you think it's going to be? We don't have any fruits. We don't have any fruits at index 2. So we could set it to something, maybe banana. List assignment index out of range. We can't just create a new entry in a list by accessing it like JavaScript. So we have to do fruits.append banana. Now when we say fruit sub 2, we get banana. So if we say fruit sub 0, what's that going to be? What's fruit sub 1 going to be? Mango. Alright, maybe that's a little hard to read. Alright, so we want to append cherry. Now if we want to say fruits sub 1, that's mango. But can we replace it now? Can we now say this is piña? Now what's our fruits look like? It just changed it in 9. So the list is definitely a mutable data type. And we can also delete it with delete fruits. Lists can be updated by providing the index, as we saw. A tuple is an immutable sequence of Python objects. And you know what we think about tuples. They're mutable. They are immutable until they're mutable. Tuples are sequences just like lists. The main difference is tuples cannot change their values. Syntactically, tuples use parentheses, whereas lists use square brackets. So you can see some tuples there. They're just like lists, but they use parentheses instead of square brackets. So this is also a tuple. Right, we can say either with or without we can declare it without the parentheses. We'll assume that we want a tuple. The dictionary. Python dictionaries are key value pairs. Each key is separated from its value by a colon. The items are separated by commas. The whole thing is enclosed in curly braces. An empty dictionary without any items is written with just 2 curly braces. Keys are unique within a dictionary, while values do not have to be unique. The values of a dictionary can be of any type, but the keys must be hashable. Like we talked about before, it's a special immutable type that's not only immutable, but it also has to be hashable, so it's a pure immutable type. Things like strings or numbers or tuples that contain only hashable entries. A Python dictionary can be created like so. The language construct here, we declare a variable, and right away we are using the assignment operator for a curly brace. And there's our key. There's our key value separator. And there's our value. So this collectively is the first entry. Then we have our comma. And there's our second entry. And a comma and a third entry. So this dictionary creates a variable we put in dict. Name Zara, age 7, class first. So to access the value, we can say dict subname, and we'll print Zara. If the key doesn't exist, it will throw an error. Only one entry per key is allowed. Duplicate keys are encountered during assignment. The last entry wins. So there's different. You can delete a dictionary. You can clear all the entries out. Now, if we now this I never tried here, but can we assign dict as a variable name? Dict equals dictionary. Now we say dict. We can override the dict keyword. So this is a horribly bad idea in programming. You would never want to have a variable called dict, because it's confusing whether you're pointing to your variable or the actual dict. See, this is how it should be. It's a class, not a variable. Something to keep in mind. Well, let's wrap up with that. And so now in assignment, we write a program which uses the 5 data types we talked about and perform some operations on each one. Okay, guys? Well, that's it. I'm going to leave it here. Next time, let's talk about flow control constructs. All right? So that's it, guys. Thanks a lot.